channel, and today I'm going to be talking about homogeneous and separable differential equations. So, we're mainly going to be talking about homogeneous differential equations, but our main ambition is to turning it into a separable differential equation. And when we turn it into a separable differential equation, what happens is we can just solve it easily and we can get our answer. So, a homogeneous equation is just an equation that has all the degree terms the same. So, for example, all the terms are degree 2, which means it's raised to the second power. So, right over here we have a homogeneous differential equation, and we have 1, 1, and 1 on all powers or degrees, so the degree is 1 for this equation. Now, what we're going to do is we want to use the separable method to solve this, but we do not have enough information to separate this, or you can't say information. What you can say is we do not have enough knowledge to separate this. So what we can use is we can use the homogeneous differential equations method to solve this. So let's first use some basic algebraic manipulation and do this. So what we can do is we can state that 9x over x plus y over x is equal to dy over dx. So this is exactly the same thing as this, except we just put the x's over there. Now we can cancel out the x to get 9x plus y over x is equal to dy over dx, and no x actually, since we just canceled out the x's, so it'll just be plainly 9. And now what we're going to do is we can save this equation. So what does this mean to be saved? Well, it means we're going to be using this later. So save this equation. Okay, so now that we have saved this equation, we can make some basic substitutions. So let's state that, so if we go over here, y over x is equal to k. So we're letting y over x equal to k, so y must be xk or kx. And then we can also state that the derivative of y with respect to x is going to be equal to k plus x dk over dx. Okay, so what does this mean? Well, and let's look at the product rule more deeply. So in our calculus playlist, we talked about the product rule because it was a very important concept in differentiation. Because unlike the regular power rule, when you have a product or a quotient, we use a specific rule for that. And when we use a specific rule, we can compute these more easily. So when we take x, the derivative of x is 1, then k. Then we're going to add it. X is just going to be x, and the derivative of k is dk over dx. So that's like that. And the reason we're not going to make it like it's just 1 is because we're taking the derivative with respect to x. And when taking it with respect to x, what happens is if we have another variable, we can't really take the derivative with respect to x, which is why we do this. Now that we have done this step, we can now combine it with this step. So what does this mean? Well, we can state that k plus x dk over dx must be equal to 9 plus y over x, which we can just substitute as v. Oh no, in this case k, then we can just leave it like this. Because when we subtract the k's, we're going to cancel them out. And essentially, we're getting dk over dx is equal to 9 over x. Pretty straightforward. Now, we've got this into a separable method, and that was our main ambition. Why? Well, we can use the separable method and get our answer. And when we use the separable method, we have to compute another step, and that step is a step that a lot of people miss when doing a homogeneous differential equation. So we will cover that step, but let's just recap what we have done so far, because this is an important process, because we're substituting so much things and even saving equations which you haven't done, or maybe have done in algebra, but also have done a lot in calculus. So we've got our first equation, which we need to solve using the homogeneous differential equations method. What we did is, essentially, we just simplified it using algebraic manipulation, and we get 9 plus y over x is equal to dx. Once you get it into the most simplified form, and it's equal to dy or dx, and we get, for example, say y over x specifically. It doesn't have to be always y over x, but most of the times when we get y over x, we can save the equation. So once we save an equation, we know that it's equal to dy over dx. Then we're going to make some substitutions. We're going to state that y over x is equal to some variable, or an arbitrary variable, which we called k. Then solve for y to get xk or kx using the commutative property of multiplication. Then we're going to have dy over dx is equal to k plus x dk over dx. Now, this identity is very important, because we know what dy over dx is, one of the main things which we should try to look for before we save the equation. We know what dy over dx is, so we also know what dy over dx is over here. So we can save that dy over dx is equal to dy over dx. Now, this is very simple, right? Dy over dx is equal to dy over dx, and everyone knows this because it's the same thing. No specific change. So, because we're now substituting y is equal to x times k, we can just essentially do this. And you might be wondering, how is y equal to x times k? If k is equal to y divided by x cancels out with the x, and you get y is equal to y. So therefore, the derivative of that with respect to x must be this, and this must be equal to this. Now that we've combined it, we can do some algebraic manipulation again and subtract the x's. So we get x dk over dx. And what we did in one step is we divided the x to get dk over dx is equal to 9 over x. Now using the separable method, we can integrate both sides to get k is equal to 9 times the natural log of x plus c. And this is very simple. And some people might conclude that this is the answer. But actually, this is not, because k is equal to y over x. And we want to know what y is. Now, we can just multiply the x and just multiply the x in front, and we can get our answer. So if we write it over here, our answer is y is equal to x times 9 the natural log of x plus c. So this essentially will be our answer. And what is a homogeneous differential equation? To recap, a homogeneous equation, or a homogeneous polynomial, you recall from algebra, has a degree of 1 or 2 or n, but for all terms. So as we see over here, we have 1, 1, and 1, and all the degree is 1. So we know that this is homogeneous. And the reason we use the homogeneous method is because if we do use the separable method, we will do a lot of algebraic manipulation, and sometimes we need to get into more advanced mathematics to even solve it. So what we can do is use the homogeneous method, in which we just do some algebraic manipulation, get dy over dx, in which we also get a state of y over x. So once we get what dy over dx is equal to, and maybe most of the times y over x, we can save the equation. Then we substitute y over x is equal to k, or any specific variable. Then, and it shouldn't be y over x because that'll get more confusing. So we'll state it k right over here, and now just make some identities. So these identities are very important because y over x is equal to k is the first identity. Because if we don't know that, the substitution over here doesn't work. So that's one identity we do make for this whole process to work. The second identity is helpful for the third identity. Y is equal to x times k, or k times x. And this is very important because we need this because we want to know what y is equal to in terms of k. Then we have dy over dx, which is also really important because we know that dy over dx is equal to dy over dx, and this is our main ambition. Now, we know our last third identity is equal to this specific expression. Now, set this expression equal to this expression, which is the one we have saved. Now, we know that dy over dx must be equal to dy over dx, so these are equal. Then, we subtracted the arbitrary variable, or k. Then we got x dk over dx is equal to 9, divided by x, and then we took the integral to get 9 times the natural log of x plus c. Then we just said that k is equal to y over x, and this is the first identity. And this is very important because some people will just say, okay, so the answer is 9 ln x plus c, and then they write that in our answer place. But they forget to write y is equal to, because if we write y is equal to, we won't get the right answer because k is equal to y over x, not y. And some people might just write k is equal to 9 ln of x plus c. And when people look at your work, they're going to be like, where did the k come from? There's no k in this expression. So we have to make it in terms of y. So k is equal to y over x, then we multiply by x, and we got our answer. So this essentially is how we solve a homogeneous differential equation. Now, let's just recap how to solve a simple separable differential equation, because a separable differential equation is our main prototype, and ambition, idea, and goal which we need to use. And an important identity is dy over dx is equal to dy over dx. And we made no specific marks over here because dy over dx is equal to dy over dx. Same notation, same symbols because they are obviously equal, and same variables in which we set this equation equal to. So, a specific separable differential equation which we want to know is this. So essentially, we can state that dy over dx is equal to xy. Now this looks easy, but actually involves a lot of processes. And you may be wondering, okay, what's the answer? Well, the answer involves Euler's number, which when some people look at is a pretty weird number, and it is. And you might be wondering how we get Euler's number. So let's work through the process. Well, we first multiply by dx to get dy is equal to xy dx. Now, what we can do is simple, divide by y. So first do algebraic manipulation, then you can do the calculus part. Because when you're doing calculus, you want everything to simplify. Only in rare cases in which you integrate, then do algebra. So dy over y is equal to, so dy over y is equal to x dx. Now integrate, we get x squared over 2 is equal to the natural log of y. Now this is very simple. Then the natural log of y is equal to x squared over 2. Now what do? Well, we take Euler's number, make it the base, and take the natural log of y and make it the power. Why? Well, the natural log and e cancel out, so we'll just get y. So we'll get y is equal to e raised to the power of x squared over 2. And remember to add the plus c. And when we're doing a separable differential equation or any differential equation, when we integrate, we just have to add c to one side. We don't have to add c to the other side because it's just unnecessary. So this is essentially a recap of how you solve a separable differential equation. So now that we have covered how to solve homogeneous differential equations and separable differential equations, we can make this video to an end. If you like this video and if you like this channel, please subscribe to learn more. Thank you.